Hi everybody, we're going to be talking about inverse functions in this video, and to start us off we're going to return to Annie and her pumpkin picking. You've seen a lot of her with the composition of function videos. So let's say same pumpkin picking function. Annie picks 3 pumpkins per hour. If she picked 24 pumpkins, how many hours did it take? So this is a really easy problem for you to do, I'm sure. If she picks 3 pumpkins per hour, and she has 24 pumpkins, then it should have taken her 24 divided by 3 hours. So 8 hours. You could probably figure that out just using your logic, but if we think about this in the way of functions, well, remember Annie's pumpkin picking function we called it P of t, where t was measured in hours, and this told us the number of pumpkins. And that's 3 times t. So what we're saying here is if P of t is 24, then what's t? Well, we would get t just by dividing both sides of this equation by 3. So 8 equals t. This is the whole idea of an inverse function. The notation we would use here is that P inverse of 24, so I'm plugging in instead the total number of pumpkins, equals 8. I'm getting out the number of hours. So let's make that just a little bit more explicit. So we have the number of hours, which we call t, and we do the p function to it to get the number of pumpkins. And that's 3 times t. This is the function we're dealing with. We could also go backwards. If we start with the number of pumpkins that she's picked, that's some number p. Then we figured out the number of hours by doing the total number of pumpkins divided by 3. Since that's how many pumpkins per hour. So this is a really simple example. We can do it with more complicated functions. So let's say that f of x equals x cubed minus 2. Then for what value of x does f of x equal 6? So what I'm really asking here is what is f inverse of 6? It's another way to ask the same question, but it's the same idea as before. We have a function, we know its output, we want to know what the input was to make it, to give us that output. So if f of x equals 6, then we have 6 equals x cubed minus 2, and we're trying to solve for x. So I'll add 2 to both sides, and I get 8 equals x cubed. To solve for x, now I just take the cube root of both sides, or raise both sides to the 1/3 power. The cube root of 8 is 2. So here we get x is 2. Could we do this if we didn't, for any number? Like what if we didn't have 6? What if we wanted to solve for 24? When does f of x equal 24? Or when does f of x equal triangle? Fill in any number you want here. Well, we do it the same way. If f of x equals triangle, then triangle equals x cubed minus 2. So triangle plus 2 equals x cubed, and then we just take the cube root of both sides to solve for x. Triangle plus 2 raised to the 1/3 power equals x. And we'll actually call this our inverse function. This is the definition of the inverse function, because then, as long as you tell me what the output should be, I'll plug that into this function, and that tells me what the input was that gave me triangle. So let's try it. When does f of x equal 12? So I could do the same thing as I did before. 12 equals x cubed minus 2, so 14 equals x cubed. So x equals the cube root of 14. Or I could just plug it into this inverse function. 12 plus 2 to the 1/3. That's 14 to the 1/3. And again, remember these are the same notation. So this is the same as cube root of 14. Let's give a definition now for inverse functions, now that we've done a couple examples. And we'll see more examples for how to compute them in a later video. So the definition is, if f of x equals y, then x equals f inverse of y. So this is a very basic definition. We're going to talk about the real official definition in a later video, but this is how you should be thinking of it for now. The normal function, you plug in an input, like time, you get at an output, like pumpkins. The inverse function, you plug in the output, like pumpkins, and you figure out what the input was that gave it to you, like time. So given a function, there's usually an inverse function that goes along with it, but we'll see some cases where there's not an inverse function that goes along with it. So let's do an example with a chart. This chart represents a function. Here are my inputs, and here are my outputs. So what is f inverse of 3? Well, f inverse of 3 is going to be the input where when I plug it into f, I get 3. So I'm basically asking, when does f of x equal 3? So I go into my column, which tells me the f of x values. It equals 3 when x equals 2. So f inverse of 3 is 2. So going back to this definition, we're saying f inverse of 3 equals 2. That's this side. So the y is 3, the x is 2. And that happens because f of 2 equals 3. So the x and the y switch roles. That's the key here. X and y switch roles. Okay, let's try one more. F inverse of 2. I'm asking, when does f of x equal 2? So I go into my f of x column. It equals 2 when x is -1. So f inverse of 2 is -1. So we'll give a more explicit definition in the next video, and we'll go through some examples of how to compute inverse functions. Eventually we'll talk about what are the cases where you don't actually have an inverse function. We'll be working with this for a while. So hopefully this got you started and excited about what's to come.